Hey, how's it going, guys? My name is Samuel Myung, and today I'm going to be covering the topic of population genetics and in specific selection. So we have a hypothetical population of bears at our location of Lake Tahoe. As you can see, there are 100 bear cubs at this location. There are 20 black bear cubs, 48 brown bear cubs, and 32 white bear cubs. Big A are the black bear cubs, big A, little a are the brown bear cubs, and little a are the white bear cubs. The first thing we need to do is calculate the frequencies of each of these genotypes. So for homozygous dominant, I got 20 out of 100. For heterozygous, I got 48 out of 100. And for homozygous recessive, I got 32 out of 100. We can also figure out the frequencies of our big A and little a alleles. We have 20 individuals with 2 big A's and 48 individuals with 1 big A. Then we have 32 individuals with 2 little a's and 48 individuals with 1 little a. We end up with a frequency of 0.44 for our big A, or P, and a frequency of 0.56 for our little a, or Q. We start off with this population and are currently in Hardy-Weinberg equilibrium. The presumption is that as these bear cubs grow up to become adult bears, some of them will die, whether that is through disease, roadkill, injuries, etc. As selection occurs, our population that was initially in Hardy-Weinberg equilibrium will no longer be. As you can see, we have a fitness value of 1 for big A, fitness value of 0.8 for big A, little a, and a fitness value of 0.6 for little a, little a. Now, based on these fitness values, we can see directional selection occurs because one extreme, or homozygous genotype, is favored. Now, our unadjusted survivors are found by multiplying our initial frequencies by our fitness values. We end up with 0.2 for big A, 0.384 for big A, little a, and 0.192 for little a, little a. Now that we have our three values for unadjusted survivors, we add them together to find our average fitness represented by W bar. Our average fitness is 0.776. Now to find the frequencies of our genotypes after selection, we divide our unadjusted survivor values by our average fitness value to end up with 0.258 for big A, 0.495 for big A, little a, and 0.247 for little a, little a. If you compare the initial frequencies of our genotypes with the frequencies after selection, you can see that the biggest difference was found for white bear cubs. When we started off, 32% of our population was white bear cubs, but after selection, only 24.7% of our population was white bear cubs. Now let's look at allele frequencies after selection. We can calculate our allele frequencies from our genotypic frequencies. We take all of our big A frequency and add it to half of our big A, little a frequency, and end up with a big A allele frequency of 0.5055. We then take all of our little a frequency and add it to half of our big A, little a frequency to end up with a little a allele frequency of 0.4945. So to recap, we went from a big A allele frequency of 0.44 before selection to a frequency of 0.5055 after selection, and a little a frequency of 0.56 before selection to a frequency of 0.4945 after selection. Thank you for listening.